Compound interest. Use the compound interest formula A equals P times 1 plus R over N to the N times T power and A equals P times E to the RT power to solve the problem given. Round answers to the nearest cent. Find the accumulated value of an investment of $15,000 for 5 years at an interest rate of 4.5%. We're given 4 scenarios. The first scenario is part A, and that is compounded semi-annually. Now we're going to use this formula to find compounded semi-annually. This formula is only used for compounded continuously. So we'll use this first formula here, and we're going to identify the values for N, R, P, and T. N is the number of times that the amount is compounded a year, and our problem tells us that the value is compounded semi-annually, so that means it's compounded twice a year. So N equals 2. R is the interest rate, which is 4.5%, and we always write the percent as a decimal. So 4.5% is the same as 4.5 divided by 100, which is 0.045. Next, we want to find the value for P, and P is the principal or the amount that we're investing. So this will be 15,000. And then T is the number of years, which is 5. Now we're going to take all of these values and plug them into the formula to find A, which is the accumulated value. So here we plugged in the values for N, R, P, and T, and we have A equals 15,000 times 1 plus 0.045 divided by 2 raised to the 2 times 5 power. The first thing we want to do is divide 0.045 by 2. When we do that calculation, we get 0.0225. And then we're going to multiply the exponents together, and 2 times 5 is 10. Now we have A equals 15,000 times 1 plus 0.0225 raised to the 10th power. Next, we'll add 1 plus 0.0225 together, and we get 1.0225. Now we'll take that value and raise it to the 10th power. And we should get 1.249203426. Lastly, we'll multiply that value by 15,000, and we get an answer of 18,738.05139. Since this is a monetary value, we need to round to 2 decimal places, so our final answer is $18,738.05, and this is our answer to Part A. Part B asks us to find the value of the investment if it was compounded quarterly. So quarterly means 4 times a year. Therefore, our N in this case will be 4. All the other values stay the same. So our principal is 15,000. R, which is the interest rate, is 4.5%, but remember we need to divide by 100 to convert it to a decimal. So we have 0.045, and then T, the number of years, is 5. I'm going to take those values and plug them into my formula for A. So I have A equals 15,000 times 1 plus 0.045 divided by 4, all raised to 4 times 5 power. The first thing we're going to do is divide 0.045 by 4. When we do that, we get 0.01125. Next, we'll add 1 to that decimal in parentheses. And I'm also going to multiply the 4 times 5 in the exponent position. So now I have A equals 15,000 times 1.01125 to the 20th power. Now we'll take our calculator and we'll raise 1.01125 to the 20th power. Next, we'll multiply the decimal that we just got, which is 1.250750521, by 15,000. And we get A equals 18,761.25781. And since this is a monetary value, I want to round to the nearest cent, which is the second decimal place. So here I have a 5, but since the number next to the 5 is a 7, I'm going to round that 5 up to a 6. So my final rounded answer is $18,761.26. Part C asks us to find the value of the investment if it was compounded monthly. Since there are 12 months in a year, our N in this case is going to be 12. And again, all other values stay the same. So our P is 15,000, our R is 0.045, and T is 5. So my first step is to substitute all of the values into my equation. Next, I'm going to divide 0.045 by 12, and I get 0.00375. Now I'm going to add 1 to that decimal in parentheses. I'll also go ahead and multiply the values in the exponent position. So 5 times 12 is 60. And then my next step is to raise 1.00375 to the 60th power. When I do that, I get A equals 15,000 times 1.251795821. Lastly, we'll just multiply those two values together, and we get 18,776.93731. Again, I want to round to the nearest cent, which is 2 decimal places. So I have a 3 in the second decimal spot, and I have a 7 next to the 3. Since 7 is greater than 5, I'm going to round the 3 up to 4. So my rounded answer is $18,776.94. Part D asks us to do this compounded continuously. Whenever we're asked to compound continuously, we use A equals P times e to the RT formula. So the variables stay the same, and we're just going to plug them into that formula. The first step is to multiply the exponents together. Next, you want to look at your calculator and identify E on your calculator. E is just a natural number, and it's a decimal number. It has a really long decimal expansion, and it goes on forever. So the calculator has that decimal programmed as the letter E. So you'll just find that button, click E, and then raise it to the 0.225 power. When you do that, you should get 1.252322716. Lastly, you'll multiply that decimal to 15,000. You should get a value of 18,784.84074. Now again, we want to round this to the nearest cent, so our final answer is $18,784.84. And that's our answer to part D.